Welcome back to the deep dive. Today, we're going really far out, like 15 billion miles far. We're talking about Voyager 1.
Voyager. An amazing mission. Launched way back in '77, right?
Exactly. Sent out originally just to study Jupiter and Saturn, then the outer planets, and now it's the farthest thing humans have ever sent anywhere, just cruising interstellar space.
It really is incredible, and it's still talking to us. But that brings us to the main point today, doesn't it?
It does, because keeping that connection alive is tricky, and NASA engineers just pulled off something, well, pretty astonishing. They've revived a set of thrusters on Voyager 1 that everyone thought were completely dead.
Yeah, it highlights the incredible ingenuity, doesn't it? And just the long-term commitment involved. I mean, its first job was those flybys, Jupiter, Saturn.
Yeah.
Then it got extended. And now, decades later, it's our only probe, actually, in interstellar space.
Right. But keeping contact. I mean, think about it. A signal takes over 23 hours just one way.
Just mind-boggling.
So these little thrusters are absolutely vital. They keep Voyager pointed the right way, especially keeping its antenna locked onto Earth. Like trying to hold a laser pointer steady on a tiny moving target billions of miles off.
And a key part of that is managing its roll motion.
Roll. Like spinning.
Sort of, yeah. Think of it like a really, really slow spin, almost like a vinyl record. It's a subtle, continuous adjustment. And Voyager uses this roll to lock onto a guide star. Its star tracker, that's kind of its navigation system using stars, needs that precise pointing. Keeps the main antenna aimed squarely back home so we get the data.
Okay. So these thrusters, let's break down the situation there. Voyager 1 has a few different sets, right?
That's right. You've got the main primary ones for the big moves, changing direction, and so on. Then there were specific roll control thrusters, just for that gentle spinning adjustment we talked about.
Right. And those are the ones that caused the problem initially.
Well, the primary roll thrusters, yes. They actually stopped working way back in 2004.
2004, wow.
It looked like some small internal heaters failed. They lost power. And, the initial thought back then was, okay, that's a hardware failure. Probably permanent. Unfixable, really.
But there's a backup.
Luckily, yes. A backup system specifically for roll control.
Yeah.
And it kicked in, did the job fine since 2004.
Well, nearly 20 years later.
Exactly. That's a long time for a backup to be running constantly.
Yeah.
And the concern grew because these backup thrusters started showing signs of clogging up.
Clogging? From what?
Just residue buildup over time. It happens. But the worry was they could fail completely. Maybe even, this fall.
Which would be catastrophic for the mission, right?
Absolutely. If Voyager can't control its roll, it can't keep that antenna pointed at Earth. We lose contact. Simple as that.
And you mentioned other thrusters. There was a third set.
Yes, the trajectory correction thrusters. TCM thrusters. They were mostly used way back during the planetary flybys for fine-tuning the course. NASA actually brought those back online more recently, around 2018, 2019, for add-to control, but not for roll.
Okay. So those TCM thrusters couldn't do the delicate, continuous roll adjustment needed.
Precisely. They weren't designed for it.
Yeah.
So the engineers were facing a very specific problem.
Yeah.
The backup roll thrusters are dying, and the TCM thrusters couldn't take over that specific job.
Okay. So a looming failure, no obvious replacement. We get the problem. What was the ingenious solution they came up with? This is the amazing part.
So here's where it gets really interesting, I think. The engineering team decided to go back, to revisit that original failure from 2004. The primary roll thrusters.
The ones they thought were dead.
The very ones. Over the years, they developed a new theory, a suspicion really. Maybe it wasn't a permanent hardware breakdown of the heaters themselves back then. Maybe, just maybe, it was some kind of electrical glitch. An event that perhaps flipped a switch somewhere in the circuitry.
Flipped a switch, like cutting the power to the heaters.
Exactly. It shows how, sometimes you need to look at old problems with fresh eyes decades later. Initial assessments aren't always the full story.
Okay, so they think maybe a switch got flipped. So the plan was, don't tell me they just tried to flip it back.
That's essentially it. A really daring plan. Try to reactivate those primary roll thrusters, the ones dormant for 20 years, and basically command that switch back to its on position for the heaters.
But that sounds risky after all this time.
Oh, incredibly risky.
Yeah.
There was a major catch. If, during this whole process of trying to restart the heaters, Voyager's orientation drifted. If the star tracker lost its lock.
Oh.
The roll thrusters are programmed to fire automatically to correct the orientation. That's their job. But if they fired while those heaters were still off, because they hadn't warmed up yet,
What happened?
potentially a small explosion, the cold propellant, the ignition, It could have been bad. Very bad.
Goodness. So keeping it perfectly pointed during the attempt was absolutely critical. Talk about pressure.
Huge pressure. You wonder what backup plans they even had if that went wrong.
And wasn't there a deadline looming, too? Something about an antenna?
Yes, adding to the drama. The Deep Space Station 43, DSS-43, in Canberra, Australia.
That's the big one, right?
Is the only one powerful enough to send commands to the Voyagers now they're so far away. And it's scheduled for a major upgrade. It's going offline for several months, starting May 2025.
It's a long outage.
A very long outage. It'll only be briefly back online in August and December 2025, then fully back February 2026.
So they needed to sort this thruster problem out before DSS-43 went quiet.
Pretty much. The Deep Space Network has other antennas, sure, but only DSS-43 has the grunt for commanding Voyager at this range. And, stepping back, those upgrades to DSS-43 are super important themselves for future moon missions, other deep space stuff.
Right. Builds on the Voyager legacy, in a way.
Definitely. But for Voyager 1, if they hadn't fixed the thruster issue before this long DSS-43 downtime and the backup did fail, well, they might have lost their chance.
Okay, so the stage is set, high stakes, a potentially explosive fix, a ticking clock with the antenna. So what happened when they actually sent the command, when they tried to flip that switch?
Well, sending the command, that was just the start. Then came the wait, that incredible agonizing wait.
The 23-hour light travel time. Each way.
Exactly. Over 46 hours round trip for confirmation. So the team sends the commands, and then they wait. Almost 2 full days. When they were watching the data come back on March 20th this year, they were seeing what had actually happened on Voyager nearly a day before.
Just wild. Puts our instant emails in perspective, doesn't it?
Completely.
So, the outcome. Did the gamble pay off? Did this Hail Mary work?
It did. It absolutely worked. A total resounding success.
No kidding. How did they know?
Within about 20 minutes of the command being executed way out there in Voyager, the team here on Earth saw the temperature data change. The temperature of those primary roll thruster heaters, the ones that had been cold for 20 years, started to rise dramatically.
Wow. That must have been the moment.
That was the confirmation. The heaters were back on. The thrusters were essentially revived.
Incredible. You can just imagine the relief, the cheering maybe, in the control room.
Absolutely. And we've got a couple of quotes here that really capture it. Kareem Badarudin, he's the Voyager mission manager, he said something like, back when those thrusters first failed, they probably didn't think the Voyagers were going to keep going for another 20 years.
Speaks volumes, doesn't it?
It does. And Todd Barber, the propulsion lead, he called it another miracle save for Voyager. He stressed these thrusters were considered dead.
Considered dead. And now they're back. So what does this mean, big picture, for the mission?
It's hugely significant. They've essentially got their reliable backup system for roll control back online. So if, or perhaps when, those currently used backup thrusters finally do give out from the clogging,
they have an alternative ready to go.
Exactly. It significantly boosts the chances that Voyager 1 can keep sending back data, potentially for many more years.
Which is fantastic. It really drives home the ingenuity involved, doesn't it? The perseverance needed for this kind of exploration.
Yeah. It really does. It's not just launching something. It's the decades of continuous problem solving, adapting, keeping these amazing machines working across just unimaginable distances.
And we should remember Voyager 2 is still out there too, right? Also going strong.
Absolutely. Voyager 2 is currently around 13 billion miles out, also sending back unique data from interstellar space. Both are vital.
So this fix on Voyager 1 isn't just, a cool engineering story. It ensures we keep getting that irreplaceable data from the edge of the solar system and beyond.
Precisely. It's a testament to that drive to explore and our ability, sometimes against the odds, to figure things out.
Right. So wrapping this up, it's just an amazing story. Against all expectations, engineers used some really clever rethinking, didn't they? Re-examining an old problem, and they managed to bring a supposedly dead system back online, billions of miles away.
Keeping a historic mission alive.
And the real aha moment for me, like you said, is that maybe after 2 decades, the fix came down to suspecting a single flipped switch. Something relatively simple, in concept at least.
Yeah, it's quite something. And maybe that leads to a final thought for you listening. Think about these Voyager spacecraft. Launched 1977. Still going, still resilient after all this time and distance.
Makes you wonder, doesn't it?
It does. What other seemingly impossible engineering feats could we pull off? If we have enough time, enough ingenuity.
And that willingness to maybe look again at old problems, old assumptions.
Exactly. What does this miracle save, as Todd Barber called it? Tell us about our capacity for problem solving, even when the problems are literally light days away and decades old.